This is a cordless drill. In this video, we'll take a close look inside and see exactly how it works. Before we dive into the inner workings, let's first understand the key components. Let's get started. Cordless drills are one of the most common and versatile power tools. They convert electrical energy into torque. They're mainly used for drilling holes and driving screws. First, let's look at the chuck. The chuck is a self-centering three-jaw clamp that holds drill bits securely. Most cordless drills use a keyless chuck that you can tighten by hand. Rotating the outer sleeve clockwise tightens the chuck. Turning it counterclockwise loosens it. Typical chuck sizes are either 10 millimeters or 13 millimeters. Next, meet the clutch collar. The clutch lets you adjust the drill's torque output by simply turning the collar. The main purpose: to prevent overdriving screws and to avoid cam out. Printed numbers around the collar show torque settings. The higher the number, the higher the torque. There's also a drill mode marked by a drill icon. This is the highest torque setting. When torque reaches the preset level, the clutch slips and the bit stops spinning. Lower settings are for softer materials. Higher settings are for harder material. Now the gear switch. Drills usually have a gear switch for low and high speed settings. Low speed means more torque, great for driving screws. High speed gives less torque, perfect for drilling holes. The trigger switch controls the drill speed. It's variable. The more you press, the faster the drill spins. Above the trigger is the forward-reverse switch. Sliding it changes the direction the drill spins. Now let's talk about power, the battery. Cordless drills today use rechargeable lithium-ion batteries. Batteries are rated by voltage and charge capacity. Voltages typically range between 12 and 20 volts. Higher voltage means a more powerful tool. Charge capacity, measured in amp hours or AH, indicates runtime. Higher amp hours mean longer runtime but a bigger battery size. Inside the battery, you'll find multiple cells similar to larger AA batteries. A common type is the 18650 lithium-ion cell. Each 18650 cell has 3.7 volts nominal and 4.2 volts when fully charged. Wiring cells in series increases voltage. Wiring them in parallel increases capacity. A battery management circuit protects the battery during use and charging. Now, let's look inside the drill. The trigger switch assembly houses a small circuit board. It controls how much voltage goes to the motor based on trigger pressure. When you release the trigger, a spring resets it and the drill stops. The forward-reverse switch operates a lever that flips motor polarity. This changes the rotation direction clockwise or counterclockwise. The motor drives a planetary gearbox that boosts torque and reduces speed. This changes the rotation direction clockwise or counterclockwise. And inside the clutch and chuck, clever mechanisms precisely control and deliver the drill's power to the bit.